Welcome all, I am Prakash Maurya. Today we'll solve some previous year GATE open channel hydraulic questions. So previously we have solved 10 questions already. If you are interested, please, or if you want to see, please visit the same YouTube channel for another for previous 10 questions. Now we'll solve 11 question number 11. So what is question number 11 actually? For a base symmetrical trapezoidal section of an open channel with a given area of section and side slope, one of the following statement holds true. Okay, so here symmetrical trapezoidal section means your channel look like symmetrical, means length, side length of channel, let's suppose this L and this L will be equal. If the slope of your channel is 1 meter, if you will go 1 meter up, your horizontal width will be M. If this is depth Y, then your this much width is My, your triangle rule. This will be also, because if you will go 1, your horizontally you will move M. So if you will move here Y upward, then horizontally how much? Ym or My you can say. If this width is B, so this will be your B. So here your top width is equal to B plus 2 times My, because one this one and one this one. And your side length is equal to what? Side length is nothing but L square. This, if you want to calculate this much length, so what will be L square equal to Ym whole square Y square. If you will take common Y square, 1 plus M square will remain. So L is equal to what? Under root. Y will be cancel out, square will be, and here 1 plus M square. So when you will calculate, when you want to calculate the best means here is nothing but your construction cost or the lining cost should be minimum for a section, for a given trapezoidal section. So this is the perimeter what I have drawn. So lining cost is very high, so we need to reduce the lining cost, so perimeter should be very less. Perimeter should be less for a particular discharge. So we apply the mathematical formulas on that when we calculate the perimeter. So perimeter, what will be the perimeter? 2 times L in plus B. L value is, you can put the L value here and you will minimize the perimeter, right? So dp by something, whatever. If you want more videos, please comment in this video section, so we'll move ahead with the all derivation regarding the best trapezoidal section or the rectangular section or the triangular section. So after the calculation you will get what? Your top width T is equal to 2 times your L, or you can say here half of the top width is equal to one side of the length. So your first option is written very well, half the top width is equal to one of the side slope. Yes, definitely it will be the correct. So option A will be the correct for question number 11. Now moving ahead with the question number 12. The downstream end of a long prismatic channel of a mild slope ends in a pool created by dam. The resulting non-uniform water surface profile can be described as one of the following. So here let us understand one by one for a new student. The prismatic channel is what actually? The prismatic channel should be throughout the channel your depth constant, your width constant, your slope should be constant. If anything will be changed, if anyone change, then your channel will be non-prismatic. Or if you want to see the top view of any channel, how look like the non-prismatic channel. If you will see here, channel width here is different, channel width here is different, channel width here is different, maybe slope different. So we are looking from the top view. This is the top view of a channel. So this is a prismatic and non-prismatic difference. So in a prismatic channel, if we look the channel prismatic channel from the side view, it will be look like that. So one dam is created here. One dam is created here. Right. Dam pool water. So let's suppose far away from the dam water depth is like that. So as you will go near to the dam, your water surface will rise up like that and water will fall like that. Right? Then hydraulic jump, then water will like that. So here question is the resulting non-uniform water surface profile. This is the non-uniform water surface profile. Here is the depth is different, here depth is different, here depth is different. So at a particular time throughout the channel your depth is different, so non-uniform flow depth is here. So can be described one of the following, whether it will be, because mild slope is already given mild, so whether it will be M1, M2 or M3. So it will be the rising profile, and it is how you will describe the M1, M2, M3. So this is your critical depth, this is your normal depth, and this is your bed. So if your flow in this zone M1, in this zone M2, in this zone M3, so your profile look like that here, and this your profile is like that. Here your somewhere is a dotted line because it's not. So there's a concept behind it, why it is dotted and all. So we'll discuss later more. If you want more discussion, please comment in the comment section. Then I will move ahead. Otherwise, I will solve simply questions. So here is profile look like that, M1 profile. So it will be the M1. So option A will be the correct for this question. Now moving ahead on the next question. The secant depth ratio of a hydraulic jump in a rectangular horizontal channel is 10.30. So here it is given your y2 divided by y1 is equal to 10.30. The fruit number at the beginning of the jump is what? Fr1 is equal to what? So you know already the formula of the hydraulic jump, the relation between your secant depth and the fruit number. So it is very popular formula. This is y1. So you can write here root under 1 plus 8 fr1 square minus 1. So when you will put the all values, 10.3 is equal to half. Only here unknown is, your unknown value is fr1. So you can easily calculate, 1 is outside of the your under root. So you can easily calculate here what the value of fr1. Fr1 is come around your 7.63. So option B will be the correct for this. Now moving ahead, water flow at a depth of 0.1 meter with a velocity of 6 meter per second. Okay, water flow at a depth is 1 meter, 0.1 meter, and velocity is already given 6 meter per second in a rectangular channel is rectangular, whether it is slope will be 0 and or any slope value, so we don't know actually, so we'll consider here slope is 0 already. It's self understood. We need to calculate here the alternate depth. We know already what is alternate depth. So when we talk about the alternate depth at a 2 section, your energy at the 2 depth, your energy will be equal. E1 is equal to E2. You know the formula already. What is the formula of specific energy? And so what you will do here, you need to calculate your Y2 value. So you can very easily calculate, but here is a two unknown Y1, here is a two unknown Y2 and V2. So how you will incorporate? So Q1 is equal to Q2, you already know, due to the mass of conservation. So A1 V1 is equal to, and this formula how it will come Q1 is equal to Q2, it is a very big reason. If your control volume is fixed, not moving, then this formula come is a big technicality. If you want to understand what is the scientific reason and what is the here calculation behind the Q1 is equal to Q2, please comment, then I will move ahead with the derivations and all. Otherwise I will solve question like that. And A2 and V2, so here your V2 is equal to nothing but Y1 B V1 divided by Y2 B V, not B. So your here Y1 Y2 V1. So this will become again. So here you put. So your Y1 value is how much? 0.1 plus V1 square. V1 already given 6 square divided by 2Z 9.81 equal to Y2 plus here again V1 square, because Y2 is equal to your Y1 V1 Y2. So here you will Y2 square into 2 into 9.81, here V1 square into Y1 square. Y1 square means 0.1 square. So here is your cubic equation. So you will get the three root 1 2 3. One of the root is 1.93. This is the valid root. So the answer for this question is 1.93, but here all option is incorrect. So always remember. So sometimes option also not correct in the given questions. So but your concept behind it, at the alternate depth you need to equate the specific energy. Now moving ahead on the next question, this is the last question for today. Water flow at a rate of 10 meter cube per second. So Q is equal to 10 meter cube per second in a rectangular channel 3 meter wide. Your B value is given 3 meter. The critical depth for this YC is equal to. Such type of question you can expect in your another competitive exam also, or like SSC JEE. In SSC JEE such type of question is very common, and in BPSC, MPPSC, UPPSC, engineering services, not I am talking about the normal PSC or normal services in the PSCs. So actually what is the formula of YC? Now come on the point. So your Q is square divided by Z to the power 1 by 3, or even another state PSCs, Tamil Nadu AP PSC, Karnataka PSC, Maharashtra PSC, Kerala PSC, everywhere you can see such type of questions. So what is the value of Q actually? 10 divided by 3. So 3.33. So 3.33 square 9.81 power 1 by 3. So your YC value come again 1.04 meter. So option D will be correct for that. So thank you for today.